Radiation can be biologically damaging due to its ability to penetrate matter and deposit energy into human tissues. Biologic damage is observed both in this Chernobyl victim who received radiation over his entire body and this patient who received a large dose of radiation during a long fluoroscopic procedure to a limited area. These effects are a result of radiation interacting at the atomic and cellular levels. The extent of the damage and the cell's ability to repair itself depends upon the quality of the radiation and where the radiation is deposited in the cell. Radiation can be classified into two types using a factor called linear energy transfer, or LET. High LET radiations deposit large amounts of energy into the cell as it passes through the body, as shown here. Examples of high LET radiation include alpha and beta radiation. However, low LET radiations, such as X-rays and gamma rays, are more penetrating. Due to this, they tend to pass through matter with noticeably fewer interactions. This also results in less energy being deposited into the cells. Due to the differences in the manner in which energy is deposited, the biologic effects from each type of radiation exposure will vary also. In addition to the quality of the radiation interacting with the cell, the location of the interaction must also be taken into account. The radiation could interact with either the cytoplasm or the nucleus of the cell. When the radiation directly deposits its energy and damages the cell nucleus, this is called the direct effect. Direct effects result when the radiation interacts directly with the key molecule which resides in the nucleus, the DNA. Radiation can damage the DNA molecule in several ways. Radiation can cause one of the base pairs to be deleted or changed, permanently altering the genetic code of the cell. Radiation can also damage the entire structure of the DNA by breaking its molecular bonds. Radiation can enter and fracture one side of the DNA molecule, making it more fragile and vulnerable to additional damage. High LET radiations, because of their ability to deposit large amounts of energy in a small area, can result in a complete disruption of the DNA molecule. In this case, the radiation is able to totally break apart the molecule. When this occurs in several DNA molecules at the same time, the cell is unable to repair itself. This results in cell death and permanent damage to the body's tissues and body systems.